So the main topic is surrounding the quantum gravity phenomena. Quantum mechanics and theory of relativity, two powerful theories that are responsible for predicting unexpected phenomena, somehow contradict each other. So how does this happen? So initially, Isaac Newton, who founded classical mechanics, viewed that space and time were distinct. But Albert Einstein's theory of general relativity incorporates special relativity, stated the perception of space and time depends on motion. So we all know Albert Einstein described gravity as the curvature of space-time caused by mass and energy. This essentially explains why planets, stars, and galaxies move and behave the way they do. Quantum mechanics deals with the behavior of energy and matter in the subatomic realm. The main problem here is that when you try to explain gravity on the quantum level, which brings us to the black hole information paradox, it doesn't work. As the idea of quantum information conservation states that the total amount of quantum information in the universe must be conserved, which is related to the study of quantum entanglement, the black hole information paradox states a process in which a black hole evaporates away entirely through Hawking radiation. And as the black hole produces Hawking radiation, it loses energy, mass, and all the information it was carrying. As Stephen Hawking is so intertwined in all of this, I wanted to read a part of A Brief History of Time, quick part of the chapter that describes the uncertainty principle. Heisenberg, Erwin Schrödinger, and Paul Dirac in the 1920s reformulate mechanics into a new theory called quantum mechanics based on the uncertainty principle. In this theory, particles no longer had separate, well-defined positions and velocities that could not be observed. Instead, they had a quantum state, which was a combination of position and velocity. In general, quantum mechanics does not predict a single definitive result for an observation. Instead, it predicts a number of different possible outcomes and tells us how likely each of these is. Quantum mechanics therefore introduces an unavoidable element of unpredictability or randomness into science. So now this brings us to the inconsistency between quantum mechanics and general relativity, as well as the search for a theory that would essentially unify these two fundamental theories. This unified theory is also known as the theory of everything, and according to ChatGPT, this hypothetical theory would provide a single cohesive framework that can accurately describe all fundamental forces and particles in the universe, including gravity. I do want to play a quick clip on Joe Rogan. Clip is titled, "Why is Eric Weinstein Scared of Edward Witten?" He brings up the quantum gravity situation at hand here. So I definitely want to bring up this clip on Joe Rogan because I'm very curious to see what you think.
Why during the 1950s did something happen that resulted in a 70-year stagnation in a field called quantum gravity? Quantum gravity is like a startup that cannot ship a product after 70 years. And it's still taken over in theoretical physics as sort of the prestige theory field.
And quantum gravity, is there an application for this that they were attempting to achieve?
It's not a precursor to technology so far as we know. But what happened was quantum gravity was a replacement for something that used to be known as the unified field. So Einstein wasn't chasing quantum gravity. He was chasing unified field theory. That fell out of favor. Unified field theory becomes sort of like a joke, old-timey expression for the future of physics. And we substituted quantum gravity for the merger of quantum theory, quantum field theory, quantum mechanics, and gravitational physics under general relativity. How is it that the field became convinced that something which clearly doesn't seem to work and has had all of the resources, all of the best minds at its disposal, it sucks up everything, and it just doesn't work?
To be specific,
Yeah.
like how many people are working on this problem? And how many people have been working on this problem for 70 years without progress?
I would say that the period between 1953 and 73, there are parallel things. Quantum gravity is not the mainstream at all, okay? So real physics is happening between 53 and 73 by anybody's understanding of it, okay? One single individual who is the most dominant mind on planet Earth at the moment, effectively Voldemort, the person whose name we are a little bit afraid to invoke and cause wrath, said in 1984, no, string theory is the way. This anomaly cancellation was unexpected, and it clearly points to the fact that we are, ladies and gentlemen, we are about to quantize.
Who's that person?
Edward Witten.
And in physics circles, you're not allowed to bring this guy up?
No, we talk about him. Everybody talks about him. But to challenge him? Think about Agent Smith. Think about playing one-on-one with Michael Jordan in his prime.
He's that good.
Joe, I don't think I'm dumb enough not to be intellectually afraid of anyone else on planet Earth at this point. I am terrified of this person.
Really?
And has never made contact with the physical world. So it's like one of the greatest conundrums. So let me get back to how
What do
crazy.
you mean by never made contact?
No Nobel Prize, never predicted something that turned out to be true, never pointed us to do an experiment that was then validated. So 100% of his efforts have been not making contact with physical reality. Oh, I'm sorry, like you have people like Michio Kaku who are in the string theoretic school, or Sean Carroll is very sympathetic to it. Mm-hmm. You need to understand this story. 1957 conference at the University of North Carolina, Chapel Hill. One of the most eminent mathematician physicists, a guy who was first ranked at Cambridge, was a guy named Hermann Bondi, an Austrian.